So probably the most important skill to really understand to be able to be successful in WRO is line following. And really, in order to understand line following, you need a grasp of the mathematics that are involved. So I'm going to sort of start with simple algorithms, and I'm going to go through more complex ones. And we're really going to dive into the mathematics of how all this works. So I'm going to start with something called a two-phase line following algorithm. But before I even get started with that algorithm, we need to talk about reflected light value. And I'm going to show you what I mean by that. So I've got my robot here, and I have a color sensor that is in front of the wheels. The further it is in front of the wheels, the smoother this goes, but this will work. And I'm going to come up here and hit the play button on the hidden menu so that I can drive the robot manually with the W, A, S, and D keys. Now, in order to get to here, I had to move the camera around. In order to do that, you just right-click and hold. When you right-click and hold, you can move the mouse wherever you want it. Find where you want the camera to be, put it in the center of the screen, and then zoom in with the middle mouse scrolling. You might even do that multiple times. And then I'm going to turn around and I should be in front of the robot. There I am. So just practice with that some and you'll get used to it. Eventually it'll become second nature and you won't even think about it. All right, so we've got the robot here. And I'm going to use port view in the actual brick here. So when this robot is sitting on top of a line, it is projecting a little red light from this down onto the black line. And the robot is recording how much of that light is coming back. So when it's on a dark line, the color black in this case does not reflect very much light at all. So it's seeing that there's almost no light coming back to the robot. If we're over on the other part of the board, you can see the red light, and it is bouncing off the table, and 100% of that light is coming back, or at least that's what it thinks is happening at the moment. We'll talk about setting sensors and stuff like that in another lesson, but for now, you can imagine this as all of this light is coming back. So once again, if you're on a dark line, it's not going to reflect much or any at all. If you are completely off of a line, you're going to get 100%. So this amount of light being reflected back is more useful when you're partially on the line and partially not on the line. So in this case, I have the light is just touching the dark line here. So I'm getting 94% of the light. So most of the light's being reflected back, but part of it's on the black line, so it's less than 100, but it's more than 0. And as I get further and further onto that line, you'll see that the numbers go back and forth to be various different things. But the point is that the closer it is to that line, the less light is going to reflect. And if I'm off the line, I'm going to get 100%. So these percentages between 0 and 100 are how we're going to use mathematics to solve this for us. So the first algorithm that I'm going to talk about. I'm going to come up to the hidden menu and hit the two-panel mode, is a two-phase line follower. So what that means is that it does one of two things. We're basically telling the robot this: if you see a lot of light, if this number's big, I want you to go towards the black line. And if you see a lot of dark, I want you to go away from the black line. So let me show you what I mean by that. All right, I'm going to manually drive the robot over here. There we go. All right, so now, if I see a number that's really low, like 0, I'm going to tell the robot to go forward and to the right. So forward and to the right. It still sees 0, forward and to the right. Now it sees a number that's bigger than 0. So now what do we want it to do? Now we want it to go back towards the black line. So we're going to go forward and left. And there, now it sees that, so it's going to go forward and right, forward left, forward right. So what we end up doing is having the robot sort of zigzag back and forth using that number. All right, so let's take a look at the actual algorithm that this is implying. So if you're not familiar with switch blocks extremely well, take a look here. All that this is the switch block from the orange section. And I have selected the color sensor to be in compare reflected light intensity mode. That is this block right here. So what I have done is I've told it, if I see a number less than 50, right? Let's think about what that means. If the number is less than 50, so let's look at the robot. Here we go. Right now it's seeing a number that's less than 50. That means it's on the black line. Right? So if it sees a number less than 50, I want it to go forward and left. So I used the steering panel and I picked a number kind of somewhere in between here. I found -60, right? So if I see the dark line, I want to go forward and left. I have this in on mode, and that means it will continue to go forward and left until this is no longer the case. Then it will move on to the next part. But we're in a loop. So that means we go back around. And it will continue going forward and left until it sees something bright. Let's take a look at the robot. All right. So we'll continue going forward and left until it sees a number that is not less than 50. So things that are true in a switch block go up here, and things that are false in a switch block go down here. So if it's not less than 50, for instance, if it is 100, we want it to do the opposite thing. We said we wanted it to go forward and right, okay? So this is forward and right, and it's in on mode again so that it will continue doing that until it sees something different. So in short, think about the flow like this. The robot checks the sensor. If it sees something dark, it is less than 50, so it will do what's up here, which is drive forward and left, and then repeat. And it will keep doing that until it sees something that is not less than 50. When it sees something that is not less than 50, it will come down here and do this instruction over and over and over again until the opposite. So there are two different things that it can do, turn left or turn right. That's why it's called two-phase. Let's take a look at this algorithm running. So I'm going to come back up to the software, put it in two-panel mode. There we go. That brings my stuff back to where I need it. And I'm going to run this algorithm where the robot is right now and see how it works. All right, so I am right-clicking and holding, so I'm holding the board still. If I let go, it follows the robot steady, not the board. So I'm going to right-click and hold so you can see it. You see how the robot's kind of jiggling back and forth? Now let's see what it does at the intersection. This will be interesting. Okay, it did fine. So the robot is sort of jiggling back and forth. That is it going through this cycle. The cycle of seeing that it's too far on the line and then going over too far off the line, then too far on the line and then too far off the line. And you can actually sort of adjust the amount that it wiggles. So let me show you what I mean by that. I can hit stop. I got to stop. This is important. If you hit stop, just like a physical robot, just because you've put it down doesn't mean that it's not running anymore. Make sure that you stop the program in here or on the brick as well. So I can actually make it go have more jiggles or less jiggles. And I'll show you what I mean by that. So I'm going to start the robot kind of on the line here. And I'm going to change this to be like -90. So, I mean, this is like a really hard turn to the left and a really hard turn to the right. And we'll run it. And when I do that, the robot goes back and forth, and it's barely even moving forward at all because it's spending all of its energy going back and forth because it's turning so sharp each time that it's going through one of these. I can do the opposite. I could have this robot pull less hard to the left. Let's say negative 50. Oops, not positive 50, negative 50. There we go. And 50. So this should be a little bit less jiggly than the first algorithm we did. There we go. So it's going, it's following the line. I'm going to hit stop here and stop here to show you how you can do that. All right, now I'm going to make it too loose, too not jiggly, so that you can see what that looks like. So let's say I took this down to negative 20 and I turned this at 20. Let's see what happens now. All right, so it is doing that. You can see it going back and forth, but watch this. The robot's going to end up, it's still turning. It's turning as hard as I told it to turn, which is 20. You can see it down below that it's running, right? But it's coming off the line real far. That's because we're not turning into the line hard enough. So you can make the robot turn towards the line real hard. You can make it turn real soft. You can also change the speed of the robot as you're going along, which will also affect it. So try this out on your own. Try it with a variety of different levels of turn and different speeds and see what results you get. I'm going to show you how to build the algorithm from scratch in case you need that. I'm going to delete this. So we just grab a loop and we grab a switch. All right. We put the switch into color sensor, compare, reflected light intensity mode. It automatically is on port 3 and 50, so that's good. We don't need to change anything. We're going to grab two move blocks, one on the top, one on the bottom, like that. We're going to put both of them into on mode. And then you're going to tell the top one to go some number that's negative and the bottom one some number that's positive. And then you also need to set the power to what you want. That's it. That's how you make the algorithm. It's really simple. Try out different things. Try to understand how, make notes in your mind about how they react at different amounts of how hard they're turning in, and see how speed affects this as well. So experiment with that. Have a lot of fun. And I'll see you next time. So have fun and happy coding.